Erik Darling here with Darling Data. I just got a haircut. I'm feeling real groovy, feeling real spiffy today. And because in honor of that, we you and me together, we're gonna do an office hours here. This is where I answer 5 of your questions, and since I have 5 of your questions to answer, we're gonna get live with it. Before we do that, if you would like to support this channel, if you would like to contribute to the Get Erik a Better Haircut Fund, you can sign up for a membership to this channel. It's the very first link down in the video description. If you think that this is a great haircut, you can do something else. You can like, you can comment, you can subscribe. And if you want to ask your very own question on office hours that I will answer on office hours, you can use a link like that looks just like this down in the video description to submit a question, and I will have a grand old time answering it. If you need help with SQL Server, if perhaps typing some stuff into a question field and getting an answer on video is insufficient for solving all of your deepest, darkest SQL Server problems, I am available as a consultant to consult, to fix things, to like get my dirty paws all over your data. Health checks, performance analysis, hands-on tuning of your worst SQL Server crap, responding to performance emergencies, and of course, training your developers via brutal bludgeonings, various implements, until they know SQL Server well enough to not cause performance emergencies any longer. If you would like to get some help via streaming video, if you would like to get some training for yourself, for a loved one, perhaps you are gonna like duct tape someone to a chair and you need something to torture them with, you can get my training content, all 24 hours of it. It's a pretty good torture sesh for about 150 USD. It's a bargain torture sesh. There's going to be a link also for this down in the video description that's going to fully assemble the discount code that you can go and get all that for. So and you can watch it over and over again. So like if you buy it once, you can torture multiple people with it. It's wonderful. I am busy, boy howdy. SQL Saturday, New York City 2025, coming up on May the 10th with a performance tuning pre-con on May the 9th by Andreas Volter. I will be there both days, handing out sandwiches and cookies and making sure no one says anything wrong. So that's my contribution. Pass is going on tour, of course, New York City, August 18th to the 20th, Dallas, September 15th to the 17th. That's the one in Texas. Somewhat ambiguous. The New York City one, not very ambiguous. Dallas, little ambiguous. Amsterdam, that is the one in Europe, the big nice one with the tulips and the museums and the baked goods and stuff. Probably no tulips there in October, but who knows? I'm not much of a horticulturist, so I couldn't tell you. Still very pretty city though. Nice time to go. And then, of course, the main event, Past Data Community Summit, taking place in Seattle, November 17th to the 21st. Golly and gosh. It's not on my birthday this year, but that's okay. I'll be celebrating anyway. And with that out of the way, though, let's answer these questions, because that's what we do here. We answer questions. All right. First up, if serializable makes deadlocks more likely, then why is serializable plus update lock considered the best way to get a concurrency safe insert update? Well, concurrency safe, I mean, the question kind of answers itself a little bit. In order to make sure that what you're doing is safe under concurrency, you sometimes have to take some locks that you wouldn't normally take to keep other things out from interfering with it. So this is the most, I mean, yeah, it is probably the most safest way to get the correct result from your data. I don't know that it is always going to be concurrency safe, right? Because you might cause deadlocks and have other things like error out, but the thing that you're trying to do, hopefully not error out, hopefully not be the deadlock victim, but it's one of those things where like if like you need like a very precise like data thing to happen, sometimes you need extra protections that wouldn't normally be available without serializable and update locks. Like sometimes you do need to lock a row. Other database engines have like a select for update thing that does something very similar. But if you are worried about things, so I think the way to answer this is if you are worried about the thing that you need to do with serializable and upd-lock causing problems for things that don't need that, right? That aren't like serializable upd-lock, like important levels of database interaction, then optimistic isolation levels will get you around most of these problems. But the reason why serializable plus upd-lock is considered the best way to do it is because it takes exclusive locks and it makes sure that nothing can mess with the data that you're messing with. And sometimes deadlocks are a ramification there. Plenty of applications have retry logic to deal with situations like this and to make sure that if two things are trying to do that same thing at a time, that only one of them can happen, and that if one of those things deadlocks and goes away, the next time it comes in, it won't find anything to do. So that's pretty much it on that. All right. Oh boy. Oh Christ, a fabric question. Why do you do it to me? All right. I saw your recent office hours video discussing Azure Managed Instance in SQLDB. I'm curious what your thoughts are on MS Fabric. Okay, so it is a tremendous waste of resources. It is 5 years, so you're saying Lakehouse and Data Warehouse. It's 5 years behind Databricks in every meaningful way. It's 5 years behind Snowflake in every meaningful way. And that 5 years is gracious for a lot of this stuff. The only people who are excited about are Microsoft employees and MVPs who are afraid of losing their stack of glass coasters. It's no one who's a serious data engineer takes Fabric seriously. They sit there confounded that Microsoft, having explored the space, this is what they came up with. It's like duct tape and bubble gum. I don't get it, honestly. The only people who I'm not a data engineer, so I don't use this stuff directly, but I talk to a lot of them. I'm LinkedIn buddies with a lot of people, and they're just no idea why anyone is bothering with Fabric. And beyond that, the people who I know who do have to work with Fabric got suckered into it because Microsoft has bribed companies with Azure credits and fake Microsoft consulting bucks to implement Fabric, and the people who end up using it are just miserable. So I don't really just as a data engineering or data warehouse tool, I just don't recommend going that route. If you want a lakehouse, use Databricks. If you want the data warehouse, use Snowflake or use Databricks data warehouse stuff. If you just want something lakehousey, data warehousey to mess with locally, you can use DuckDB for free. It's just absurd. Anyway, let's end that there. Do you ever change any settings in sys.database scope configurations? Hell yeah, I do. My favorite setting in there is the one that forces the legacy cardinality estimator. This helps in two situations. One, if you have already changed your compatibility level from a lower one, like a pre-2014 one, to a higher one, and you're having problems all of a sudden because of that change, and you're using the new cardinality estimator, just flipping back to use the legacy cardinality estimator can often bring you back to earth without losing the stuff that might be useful. See, Microsoft hides a bunch of stuff behind higher compatibility levels. That's new T-SQL functionality. That's new query, optimizer features, the intelligent query processing stuff. Different stuff is available at different unlock levels. So if someone's hey, I really want to use compat level 150 or 160, I want batch mode on row store, but I'm afraid of this new cardinality estimator because it's kind of a tire fire. You can use the database scope configuration to force the legacy cardinality estimator. Keep the cardinality estimator that you know and love and you're happy with, or at least isn't causing your server to spontaneously combust. And then you can try out the new optimizer features. It's a little bit of a best of both worlds thing. Let's see here. Here we go. Do you consider in the near future to make videos about Columnstore indexes? Well, what would you like to know about? Help me help you. I don't know what I don't know what people are yearning to know about Columnstore. I've asked a few times, hey, what do people care about Columnstore? And people are like, yeah. And I'm like, well, cool. What do you want to know? And they're like, oh, well, if you tell me what you want to know about them, that would be helpful. Otherwise, I just kind of talk opportunistically about how either a Columnstore index can help with a certain thing performance-wise, or by extension, batch mode can help with certain things. But like doing like detailed training on like Columnstore indexes, I don't know what would be useful to people because I don't know what you're looking to do with them. And finally, last but not least, maybe it is greatest, I don't know. I found your post on using views to reduce memory grants very helpful. Since that post addressed an architectural issue with the data, do you have any other strategies for dealing with data structure issues like implicit conversions? So the memory grant one was very specific to so for the folks out there who haven't read the post or haven't seen it, or maybe they've seen it and just stared blankly at it, I discuss using a view to it was a sort of like a dummy thing where like there was a table that had like a bunch of nvarchar max data types in it, and but the thing is that none of the columns actually needed the max data type. They were all like 100 or 200 bytes in length. And so I used a view to wrap the table up with like a, like column equals like convert and varchar 100 or 200 or whatever was appropriate for that column, so that SQL Server wouldn't estimate gigantic memory grants. Because like part of what really inflates memory grants in SQL Server is string data. SQL Server guessed that it's like every row is half full byte-wise. So it especially if like you're not filling those rows up, the memory grant gets huge for no reason. You end up with like a query that asks for like a gigantic mini gig memory grant, but uses like a few hundred megs of it at the end because it didn't end up needing all that stuff. So, but for something like implicit conversions, I'd be far more apt to use something like a computed column. If I'm really desperate, maybe an indexed view, but it sort of depends on like where the implicit conversion is coming from and where, like if it can be fixed in another way that doesn't involve changing the database structure, because that's often a little more difficult. But like the nice thing about creating computed, like, so where computed column would be useful, where a view wouldn't be here, would be something like, if you had to, like, if you wanted to like index that column, you can't, like, unless you create an index view, you can't like separately index the view without like schema binding and unique clustered index and obeying the 7 like weird laws of index view creation. But for something like implicit conversions, I'd probably be more inclined to use like a computed column for that, because then I can index the computed column as well, and it like life gets a little bit easier for the query when you do that. But stuff like that, usually I would rather fix like either the problem with the code that's like implicitly converting stuff. Occasionally, if it's like a join problem, like I see a lot where like I don't even quite get how it happened, but like someone created one table where the ID column is an integer, and someone created another table where the ID column is a varchar, and like when you join them, it's a nightmare. So sometimes it, like in situations like that, like the computed column can be really helpful, because you can like do like a try cast. Like some people will be like, oh well, we sometimes have like the letter A in the number, and I'm like, great. Data integrity, folks. So like you can do like try cast or something, and then like try cast that column as integer. Try cast is usually a little bit safer to use, because like try convert is only available in like compat level 130 or 140 or something. So like you can, or 130 and up. So like if you try convert like a newer version of SQL Server, again the compat level thing, but you're using an older compat level than like 130, it'll be like, I don't know what try convert is, but try cast works back to like SQL Server 2008, I think. So like they're like for implicit conversion specifically, I'm way more likely to use a computed column, because I can index that and make life a lot easier for the query generally. But I would prefer to fix like whatever code the implicit conversion is coming from, if that's the source of it. Sometimes it's an ORM where developers didn't strongly type or didn't map correctly like the parameter to like the column that's going to be hitting. They just like did it like lazy boneses, and you ended up with like an varchar 4000 parameter for, you know, a varchar 10 column or something. But you know, that's probably the main one that I would do there. Anyway, I believe that is 5 questions. So we're gonna wrap this up here. It's been a pleasure. It's been a real joy. Thank you for watching. I hope you enjoyed yourselves. I hope you learned something. I hope that someday I can afford outro music to these episodes. And I will see you in the next one. I don't know what it's going to be about just yet, but promise you it'll be enthralling. And if not, a full refund. All right. Thank you.